Hello and welcome to the MRO Show presented by Chadwell Supply. I'm your host, Adam Porter. Chadwell Supply is 100% dedicated to the multifamily industry. Your order is on our truck delivered the next day. Learn more at chadwellsupply.com. In this episode of the MRO Show, we're going to take a deep dive into one of our new A2L refrigerant options, R32. To help us have that conversation, I'd like to welcome King Tong with Goodman Manufacturing. King, it's so great to have you here today.
Yeah, Adam, thanks for having me.
And welcome to the MRO Show.
Yeah, this is really excited to be here. Great studio, great building. Real excited to be here today.
So tell us a little bit about what you do with Goodman.
Yeah, so I work as a director of product management on the residential side with Goodman. I've been with the company for, let's say, 10 years now. Mm-hmm. I started out in oil and gas, actually, working as an engineer. And then I wanted to do something a little more dynamic. And so I found a role as a product manager at Goodman. Really did not expect here to be, with the HVAC industry that long. But here I am 10 years later. It's a lot of fun. Work is very interesting. And it's just a really interesting, industry to be in. So
working as an engineer, if something isn't going right in somebody's AC unit, you're the guy they need to call, right?
Well, just call me on the good stuff, not the bad stuff.
Absolutely. And there is a lot of good things with Goodman. Goodman is one of Chadwell Supply's best partners. We have a long-standing relationship. And one of the reasons we do is because of the quality of the equipment you guys continue to produce, whether it's some of the legacy refrigerant equipment or some of the new A2Ls out there. You guys are doing a great job, especially for the multifamily industry. Talk to me a little bit about the approach Goodman has with developing equipment for multifamily.
Yeah, when it comes to multifamily, obviously this is a segment that we understand is very, very large and very important. In recent years, we've seen a lot of growth in the multifamily segment. With Goodman Manufacturing, we want to make sure that whatever equipment that we produce, we make it very easy to sell, easy to install, and easy to service.
Easy to sell, easy to install, easy to service. I know our maintenance technicians out there love that.
Yeah.
So the entire multifamily industry really has been impacted by the phase down of R410A. Now, it's not a phase out. It's not what we dealt with R22, but it is a phase down. And we're about to hit another one of the big deadlines here at the end of December here, 2025, the deadline for the sale of all R410A equipment. So looking ahead, what is Goodman doing to address this transition?
Yeah, so Adam, as you're fully well aware, the DOE and EPA have prohibited manufacturers from producing any more R410A equipment starting this year. But we also are very understanding of the real life practical situations that multifamily developers and contractors face and needing to have R410A equipment, such as maybe they spec'd out a project that requires R410A equipment. We know that sometimes there's different timelines with the outdoor being placed before the indoor. So we were very committed and focused on producing R410A equipment all the way up until the deadline so that we do have some inventory in place for situations like that.
When we're talking about working with a split system, because I know in the multifamily industry, we like to replace the condensing units, not necessarily the indoor units. They're looking to replace the outdoor. So Goodman understands that. Again, long-standing relationship with Chadwell Supply. You guys understand the multifamily industry. It sounds like you've prepared well to meet the needs of our customers.
Yeah, absolutely. And we also, on the indoor side, I know you mentioned the outdoor, but on the indoor side, we have, service coils, readily available and ready to order in case you need to have replacements. So we have a lot of, equipment. We have a lot of processes, established and set in place for servicing R410A if need be.
So there are a lot, when we hear from our customers, one of the things they do talk about is we're looking for options. Mm-hmm. Some of our guys, maybe they're comfortable with 410. It's what they're familiar with. It's what they understand, what they're used to working on. Maybe we're not ready to make the investment in the new A2L technology. We want to go ahead and stay with 410A. So we're giving them options out there.
Yeah, absolutely. But as you mentioned at the top of the podcast, there is a finite period in which you can continue to sell and install R410A systems. And, that's through the end of this year, essentially.
So let's talk about that because the decision point is coming. And you mentioned it, you alluded to the EPA. This is not something that nobody in any industry related to AC is lined up and say, we want to make a major change in our equipment. We want to start looking at ways to completely retrofit everything that we're doing, whether it's a single family home or a multifamily property. The EPA has made some decisions and we have to follow through with those regulations. We got to do what they say. It's part of the deal. So we had two choices come onto the market. We have the two A2L options, R454B and then R32. What was it about R32 that made it Goodman's choice?
So before we dive deep into maybe the reasons why we decided R32, I think it's probably important to understand the background of Goodman and what makes up Goodman and why Goodman. So Harold Goodman, Adam, I don't know if you know the history of Goodman Manufacturing, but Harold Goodman founded the company in 1975. And before he founded the company, he was actually a very successful HVAC contractor in the Gulf Coast. I think he's probably like one of the largest there. So when he created this company, it was always with dealers and contractors and service technicians top of mind because that was the life that he lived. And so Goodman's philosophy when it comes to designing products really centers around three core beliefs. And it's something I mentioned earlier. Designing products that are easy to install, easy to sell, and easy to service.
Install, sell, and service.
Yes. So when it came time for Goodman to determine what refrigerant they wanted to use, we wanted to use, it was pretty simple. But I wouldn't say it was a foregone conclusion for us choosing R32 because at the end of the day, we wanted to do right for our customers. So we actually evaluated the alternative A2Ls. We looked at R454B and we tested it, we researched it, and at the end of the day, after all was said and done, we felt that R32 was the right choice for our contractors.
Yeah, and we do want to say, at the end of the day, if any people listening to this have made a choice, they've already gone with R454B, it's a perfectly good refrigerant. It's going to get the job done. It's safe to use. It's one of the issues that people had with A2Ls. There's a little bit of worry about safety. R54B is a good refrigerant. It's safe to use. But as you said, Goodman looked at R32 and said, this is the best choice for us because we understand HVAC customers. So walk me through some of the points, King, about why R32 was the choice.
Yeah. So remember, our core philosophies at Goodman, designing products that are easy to sell, easy to install, easy to service. So let's touch on those three first. So when we think about easy to sell and why R32 is easy to sell, fundamentally, you can only sell what you have. If you don't have something that's available, you can't sell it.
That's fair, yeah.
And so I know that we're going through a really tough time, in the business right now with availability. But that's sort of the foundation of, why something is, maybe easy to sell, right? You need to have it in the first place.
Right.
And this was actually something that we forecasted, with R32. And a lot of it was because R32 is a single component.
Right.
I'll go over this a little more in detail later and why that's important. But when it comes to easy to sell and sort of the economics of it all, R32, single component. R454B is a blend. It's made up of R32 and R1234YF. Now, because it's a blend, right, you need to make sure that you have ample supply of both of these things, R1234YF and R32, in order to make R454B.
Right.
Do you like ice cream?
I love ice cream.
What's your favorite ice cream flavor?
So I am it's funny. I'm a Ben & Jerry's guy. There's a couple that I have. If I'm just looking, it's a cookie dough. I'm a fan. But there's one called Half Baked. Because I am a blend guy, and I like to have, it's chocolate and vanilla with brownies and cookie dough in it.
Okay.
It's a bit of a kitchen sink.
Well, here's a half-baked analogy. So with ice cream, right, my favorite flavor is actually vanilla.
Okay.
I know it's a little bland, but it's what I like. It goes well with everything, right? I can put it in a root beer float. I can put it on apple pie. Very versatile. Yeah. A lot of different applications.
It's great for breakfast, lunch, and dinner any time of day.
Yeah. And Neapolitan ice cream, right? Neapolitan ice cream is made up of chocolate, vanilla, and strawberry.
Right.
So in order to make Neapolitan ice cream, you need to make sure you have chocolate, vanilla, and strawberry. If you don't have chocolate, or you don't have vanilla, or you don't have strawberry, it's not Neapolitan ice cream.
So yeah, it's a great analogy, King.
Yeah.
I like that.
Yeah. So, that's why when it comes to availability, right, having a product that's single component versus a blend does make a big difference. When it comes to easy to install, R32 refrigerant has better thermal conductivity properties than both R410A and R54B. So how we translated that into the equipment design was especially in the heat transfer, portions of the equipment, and we were able to optimize it. And, in aggregate with our outdoor units, you'll find that, our units are in some cases smaller or lighter, which means that it's going to be easier to transport. So there's a lot of logistical, storage, delivery benefits because of this.
And there's some final end user benefits too with smaller and lighter. I know we looked at that with our brothers' units too. Having a smaller, lighter unit in multifamily, you're running along the side of a complex. You want to have as much airspace in between the units as you can, but you still got to fit 6, 8, 10 units along the side of a building to service your customers, service your resident. It's nicer when they're smaller to have a little bit better airflow.
Yeah.
So one of the big things about R32, in addition to what you were talking about earlier, is the fact that it's a non-proprietary refrigerant. So there's more of it out there available. You talked about it's easy to buy, it's easy to sell. There's more of it out there, but you can get it for a lower price than some of the other options out there. So that makes a lot of sense for somebody who's on a tight budget, who's looking to upgrade. Maybe they didn't have that on their dance card this year because they waited a little long or they weren't as familiar with the changes. But now, you mentioned earlier, decision point time. So they're paying a little less for something they're going to have to do anyway.
Yep. Great point, Adam. And, fact of the matter is because it's non-proprietary, there is ease of, manufacturing with this, versus some of the other blends out there.
So let's talk a little bit about handling, because you mentioned the blends out there. But again, this is a single component. What are some of the end user benefits of a single component refrigerant?
Oh, I love this, Adam. When we actually surveyed dealers and contractors, early on in this, on this project, we gave them all the benefits and, listed them out. And by far the one single factor that resonated with the dealers the most was the fact that it was a single component. And so why is that important? Well, it ties into the third piece of the Goodman philosophy, which is easy to service, right? Yes. So easy to service. So single component versus a blend. The important thing of that has to do with temperature glide. Mm-hmm. So I know the term has been, thrown in there, out a little bit. And, if I can condense and reduce it to, more simplistic terms, like temperature glide is basically the difference in temperature between the boiling point of that first refrigerant that makes up the blend versus the second refrigerant. Mm. So basically, it's the difference in boiling points, a phase change of the two refrigerants that make up a blend. Mm-hmm. So why is that important when it comes to application, when it comes to servicing? Leaks occur, right, Adam?
That's a fact. Yes.
Leaks can occur in the system, in the line set. And with a single component like R32, if there's a leak, easy to handle, easy to top it off, right? R32 is R32. You don't have to worry about temperature glide.
You know exactly what's in there.
Exactly. So temperature glide is literally zero because there's no difference in two different components that make up that refrigerant. Mm-hmm. It's one single component. Whereas with the blend, you do have to worry about a difference in boiling points.
If it's leaking,
a phase change.
How much is in there? What leaked out?
Exactly. Yeah. You got it. So what happens with a blend like R54B, there may exist a leak that occurs in the line set. And it may occur at a point where the phases are different between R32 and R1234YF, which make up R54B. So R54B is not just R32 and R1234YF. It's 68.9% R32 and 31.1% R1234YF. If they exist at different phases and there's a leak that occurs in which there are different phases, one may be leaking at a faster rate than the other.
Yeah.
And so it's no longer 68.9 and 31.1. That composition may change.
Right.
And when that ratio and composition changes, it completely compromises the integrity of that refrigerant.
The properties are different. The effects are different. The expectations are different. And every other element that you expect from that, from a performance standpoint, is not going to be what you expected.
Correct. It's no longer R54B, right? So what you need to do in that case is you need to evacuate the entire system and then recharge the whole thing. And so we think about what it means for the contractor at the end of the day, the service technician, right? Okay. Cost it takes to evacuate it completely and then recharge the entire thing.
Time is huge for multifamily properties. We talk about it a lot here on the MRO show. These maintenance technicians out there, their service orders, their stack is not getting any smaller.
Mm-hmm.
You know, they have something to do whenever it is they finish getting this done. Mm-hmm. So if they're having an issue with an air conditioning unit, maybe they have a certain amount of time allotted to it. It takes twice as long. Or if they realize, oh, I got to evacuate this whole thing and recharge the entire unit. Something else that they have on their to-do list that's been waiting to get done isn't getting done.
Exactly.
So,
time is money.
So let's talk. We've talked about some of the benefits. Let's talk a little bit about the concerns. And one of the things that everybody out there is living life on social media these days. We all read it more often than we probably should. Let's be honest. Yep. And there's a lot of myths. There's a lot of rumors. There's a lot of speculation about R32. R32 has been around for a few years. And I think I saw something the other day, the conversation, when is it going away? When is it going away? Well, it just got to the States. It just got here. It's not like the guest is going to pop in, stay for 15 minutes and leave. This is a good refrigerant. It's a quality technology. It's going to be around for a while. Let's look at right in the eye and address that challenge that R32 is going to go away in a few years. King, tell me about that. What's Goodman's position on R32 being gone in a couple of years?
Yeah, Adam, I've heard this rumor, countless times. And the fact of the matter is, DOE and EPA, there are no current conversations about reducing the GWP requirements for refrigerant any further. Now, anytime they make a ruling, it takes some years for it to be implemented. So the fact that there are no conversations happening right now means that it's not going to happen in the foreseeable future. But even if, and let's say when that happens, we believe that it won't be a small incremental change. We believe that it will be a substantial step decrease. Think about R410A versus R32, right? R410, did you know what the GWP is for R410A?
Isn't it in the 2000s?
2088.
Yeah, it's big.
Okay, so 2088 versus the GWP requirement that we had here to less than 700.
Yeah.
That's a big step change. And so we suspect that something similar will happen when that time comes.
And we've just seen a big change. We've just seen an industry reset. And like we saw with the transition from 32 to R410A back in the early 2010s, 2012 timeframe, it's been a lot of years since then. It took a lot of time. But the fact of the matter is, it's been a big transition. It's been a big pill to swallow for a lot of our customers. A lot of Goodman and other manufacturers have had to do a tremendous amount of R&D and investment to make this transition. And no politician out there is in a hurry to make another big change.
Correct.
Yeah. So we have our 32. It's going to be around for a while longer because, again, no conversations beyond the rumors on the Facebooks out there.
Yeah.
Facebook and X, they'll tell you anything you want to hear. You can find that conversation if you're looking for it.
Yeah.
I heard somebody tell me it's going to be 27 the other day. They're going to phase it all out. And so that's going to be interesting because we're going to have rolled it out by then. Yeah. You're not going to phase it out as soon as you're rolling out. That process is not going to overlap. It's going to be a lot of years if and when it does happen.
Yep.
But speaking about a lot of years, the other issue that we see, the other conversation and concern, and this is honestly a legitimate concern, it's a change. There's a difference between an A1 refrigerant and an A2L refrigerant. Let's talk a little bit about the concern, King, with the mildly flammable or the A2L refrigerants in general. What are some of the reasons why we know that R32 is a safe, reliable option?
So in trying to adhere to the new GWP requirements for refrigerants, we basically had to shift, the refrigerants that we're using from an A1 classification to an A2L. And what A1 means is that second number right there this is a non-flammable refrigerant. A2 is a slightly flammable refrigerant, but we needed to go there in order to satisfy the GWP requirements.
Yes.
All the refrigerants out in the marketplace right now, whether it's R32, whether it's R54B, they are classified as A2L. Now, every single manufacturer, what they've done is we've put in some equipment and components such as refrigerant detection sensors. We've established some protocol to mitigate the hazards so that a leak of refrigerant doesn't become a substantial risk, right? So this is all stuff that we've done for A2L refrigerants. But I think the biggest thing when it comes to R32 and why it sets R32 apart versus something like R54B is that R32 has been used on a global scale worldwide in all countries, right? Whether it's China, whether it's Japan, whether it's Australia, since 2012, it's been used by 50 different companies and competitors, over 280 million systems installed.
I was going to say that was the number I was heard before. 280 million systems installed, and that statistic probably has grown since we've started installing R32 units here in the States.
Yeah, absolutely, and it's going to continue to grow. And why that's important is when you think about this from a practical sense and even from a business sense, right? If R32 was such a danger or such a concern, no one would be using this.
Right.
Let alone 280 million times, right? So this is trusted. Even our competitors who use R54B locally here in the United States, they're using R32 in their equipment somewhere else in the world.
I'm not as much of a numbers guy, King, as you are, but as an engineer, if there was a problem, would we know about it?
Exactly. So R32, it's been in the marketplace for a very long time. It's trusted and it's established a lot of credibility.
So a slightly statistically elevated risk that's been mitigated by good engineering and a good forethought by trusted people and big brands in the industry who understand their customer base. How does R32 compare to 410A?
Yeah, so it's funny because I don't think a lot of people know this, but R410A is made up of R32 and R125 in equal parts. And what R125 is basically it's a flame suppressant so that it can qualify as an A1 refrigerant, right? But it has obviously a very high GWP. So if you sort of view what R410A is, it's basically a diluted, watered down, non-optimized version of R32.
So it's an R32 version that works okay.
It works okay. And so now that we've moved to pure R32, we can fully take advantage of the thermodynamic properties that are superior and put that into our design, right, in our equipment. Make sure that our customers see some improvement in their serviceability and their install, save them some money and time as well. Make it widely available. So a lot of benefits with R32.
One of the statistics that I saw that jumped out at me, because we like to talk about capacity. Because again, we're trying to save our customers time and money. And that 10% more capacity as compared to 410A, that's an interesting statistic because it doesn't sound like a lot. But if I take that 10 and I multiply it across 100 units, 200 units, 300 or 400 units on a property, suddenly that's a lot of time and money I'm saving.
Yeah. And I'll tell you how else it translates. So R32 has smaller pressure drops with lower friction losses when using long line sets compared to R410A. So what that means is that I am able to get the same performance, the same capacity, same efficiency using less refrigerant. So when we think about this from a dollars and cents standpoint for contractors out there and for developers, I'm going to use 3 ton as an example.
Sure.
So 3 ton, if you're using R410A refrigerant for line sets 15 meters and longer, you would need to use a copper diameter of 9/8 inches.
Okay.
With R32 for runs of 15 meters and longer, you can reduce that down to 7/8 inches. So that's a savings of like a 1/4 inch diameter in copper tubing. And so it compounds the savings here, right? And the benefits.
And it's a practical benefit for a lot of our customers out there. They're running long line sets, frankly.
Yep. I'm using less refrigerant to charge the unit, right? And I'm saving a little bit of money on the copper line set in itself. So it adds up. Mm-hmm. It's additive, it compounds, and it results in big savings on a major project for multifamily.
So, King, one of the things I want to touch on here, don't want to get down too deep into the numbers, a little too wonky on us right now, but I do want to talk about R32 has been shown to be more efficient. When we say shown to be, is because we have 13 years of a track record working out in the field in multiple different environments in multiple different countries. So we know how this refrigerant is going to act in hot climates, in cooler climates, in drier climates, in more moist climates, if we were. Because I know you're a Texas guy, I'm a Florida guy. Humidity is a thing that we live with. We don't always love it, but it's a reality. And when you're dealing with air conditioning, humidity matters. So we've seen performance, and we've seen greater efficiency. And then also, R32 operates with that efficiency and less of a refrigerant charge as compared to 410A, if I understand that correctly.
Yeah. There's, as I explained from a line set standpoint, right, you can, use less refrigerant to charge, but even our equipment in itself, we were able to optimize our heat transfer and our heat exchangers so that we don't have to run as much refrigerant in there. But that doesn't mean that we don't have more efficient products and more efficient systems. In fact, even though we're using less charge, our R32 systems are rated higher SEER than SEER 2, I guess you'll call it now, than R410A. So we have, let's say, base efficiency, right? 14.3 SEER 2 for heat pumps, for example.
And these are third-party rating systems. This is not statistics coming from you guys.
These are ratings in HRI, and if you want to check it and
go to the website,
see whether I'm lying or not, go to HRI and check yourself.
Yeah, you can put the model number right in there and it'll pull it up. Yeah, the spreadsheet, compare everything apples to apples.
So our average rating for our base efficiency 14.3 SEER 2 products, the majority of our systems used to be 14.3 SEER 2, right? With our 410A equipment, we're getting the minimum that is required to adhere to the standards. Now we're seeing those same systems being rated 14.5, in some cases even 15.2.
It's impressive.
Being the industry leaders, we do feel ourselves as being caretakers and good stewards of the entire industry.
That's definitely pairs well with the Chadwell Supply philosophy. It's 100% dedicated, you guys are, to HVAC. We are 100% dedicated to multifamily. We're out there trying to give our customers options. So, King, thanks again so much for taking time to sit down and talk with us on the MRO show, for breaking down why R32 is a good choice and why Goodman continues to be a trusted resource in the HVAC industry.
Yeah, thanks a lot, Adam. This was fun. Hopefully we can do it again.
I'd love to. Thanks so much.
All right.
And thank you for listening to this episode of the MRO Show. If you found this episode helpful, please rate us 5 stars on your favorite podcast service and look for more episodes of the MRO Show at chadwellsupply.com/podcast.